This video shows how to reverse engineer buffer overflow attacks and apply security concepts into legacy applications. By creating a set of 4+1 views, we can discover vulnerabilities in the software that can be exploited. The next step is to transform an insecure legacy system into a secure target system. Before we inject security features into our source code, we need to draw a use case view showing a success scenario that demonstrates secure system behavior among all actors. We can see that a user can enter his credential, and upon successful authentication, he or she can view his or her account and make a transaction. When a hacker attempts to enter a long string on the username or the password fields, the system will ask a hacker to re-enter his or her credential. Now we create our secure process view. In an insecure process view, we spotted the exact location where the vulnerability happens. At that location, we need to utilize the fgets method to accept inputs from users. The fgets function specifies the maximum number of characters to be read, including the final null character. In addition to using fgets, a validation of the user input should occur before the input is processed, so when a hacker enters a very long string, the system would just truncate the rest of the characters and display an error message to the hacker. To avoid buffer overflow attacks, our approach is to choose the appropriate functions to use and perform a boundary check on the buffer. In the previous code, we used the gets function to read characters from standard in. Instead of gets, we should use fgets. The ending new line character is not included with gets. However, by using fgets, the new line character is included. If a user enters more than max size, the rest of the characters will be truncated. We can also perform a boundary check to limit users' input. In this case, the user is forced to enter only a certain number of characters, specified by a variable, max size. Additionally, in the case of a password, all secure systems should display asterisk characters instead of just plain text. By implementing all three security features, we develop a more secure codebase that has a higher chance to reject a buffer overflow attack. Now, when Marvin attempts to log into the system using an invalid username and a random password, the system rejects Marvin's input and asks him to re-enter a valid credential.